Here we are again. Hello. Hello. I still don't have the hand tracking configured properly. This is still everything very much improvised. And also I'll have to remind myself where I stopped earlier today. So let's get to it. I added a very quick and improvised sticky note to keep track of what needs to be done. I have my own task list, but this way I can write it out in a mostly readable form for anyone who would be interested. And I believe I'm going to actually start with the second point on the list, which is the generator activation code, as that should be fairly easy. And pooling, while it will help a lot, and it is crucial later on, it's technically speaking not completely necessary. At least not for the testing phase. Right, all the way down here. What I need to do here is basically make sure that generators that are set up, ones that have to run, which is the ones that have the required generator counts, which is important for stairs, for instance, and that's the whole reason why I even thought to do it. There is a possibility that the room won't spawn, that there won't be enough rooms with those generators to fulfill the conditions, and should that occur, it is necessary to have some kind of fallback mechanism so that the stairs still generate and you can actually progress. And the AI is correct on a part of it, as instead of skipping it, we need to call not this one. The key generator fallbacks for the generator set key needs to be called with the list of generators like this. Oh, yes. I think that's it, at least in this part. I genuinely can't remember if there was something else. If so and I've missed it, then it will be something to debug later, I guess. For the time, I suppose a part of this step is to actually set it up so the generator exists, and yeah, I really should put that on the list. One moment. There. That's actually something that matters. And over here, I do believe I have it already. So I wonder if this can do doesn't seem like it. No, you can't make it crossed out as far as I can see. And I did not prepare for that, so I'm just going to erase it and do things that way. And yes, star generators would, I suppose, be the next step. Although now I am slightly questioning. No, I still want to use this. I would want a more general class of a generator. So I guess they should have their own folder now. Tools. Yes. Remove the generator and then we create the class for spawn spawn tiles generator. Let's call it that. And of course it needs to be a public class deriving from generator itself. And this will hold I suppose a list of tile keys. It might have a string then. Empty by default. Spawn count is correct. And then we would want to override specifically this generate. And while I'm at it, in the generator, it would be good if this threw an error if I mess up and call them since they aren't set up. Option. Open. And same over here. Then spawn tiles generator. What it needs to do is pick two of these generators at random. Hi, welcome back. I take it I should be expecting you on Mondays. Well, you're going to see the exact same thing as probably for the rest of the stream. just code without much demonstration because backend work. Am I now? Is this better? Alright, if there are less generators than tile keys length times spawn count, then we throw an error because that should not happen. But it does not happen. If that does not happen, then we want to pick. Do we want to pick the generators, or would it be more efficient? I guess list generators to use. Would be this, but first shared key generators. Right, so this will also have to access the random number generator of the map builder. The generator from the map builder, which currently is not accessible. So I guess we're making it public now. I don't know if it's if map builder should be the one holding the random generation seed, but I guess it's fine for now. Anyway, here we order it by map builder. Well, it's, I think, this. Brown.next. No, it won't be null there. We can ignore that, probably. So then, in a loop that we repeat for spawn count, we do a different kind of loop for each key in tile keys. Right, this is the time that I mentioned that I will have to go for a few minutes, so see you in a bit. Right, I have returned. And also I realized that I can actually show something more than just the editor. Because what are you even talking about? But I'm not going to question it, but since you are still here, I should be able to actually show the fallback stack generation. Actual generation isn't available yet because I was just writing the code for that generator. But also adjust your expectations. All that's going to happen is that two of the dots will be replaced by arrows if that works. And also, the app actually has to build first. Not sure how long that will take. Okay, we might have something. And do we have it? Why is it taking so long? We do not. Hey, it didn't work. Well, sorry for the disappointment. Have fun at work, I guess. Oh, also, there is a generation back here. This is not connecting anywhere. So I guess I have to save that seed and later see what went wrong. Well, I feel like that is your fault for putting the trust into this stream being anything worth watching. You're welcome. Also, apparently you've been here for 13 minutes, 23 seconds, not 15. So, false advertising. Either that or YouTube is lying to me. All right. So we'll do that. We'll do right exactly that. And see if it gets called in the first place. Okay, so from this, looks like the fallback wasn't called at all. Since that happens after the corridors are placed and there are no logs. So that's at least slightly more interesting than backend work. The fallback stairs generator does exist. It is in the dictionary, and the dictionary is being called. Oh, I see what's going on. What is going on is that if there are no generators, the key doesn't get registered. So we would have to get a list of the forced generations that weren't actually called by this set. That, or I think that's actually a better idea. We will go to the definition of key generators. We initialize it. I think you can do it like that in this version of C#. Seems like you can. We initialize it. Well, we can't do it that way actually. We need to add it. But the point is that we create the keys in the dictionary, even if they don't have generators, for the stuff that we must have. So for each item in required generator counts, key value pair, right? Yes, it is a dictionary. So key generators, add key value pair key, and can you do that? Apparently you can. Now it should actually generate the stars. And here they are. For now, it's just a fallback. So the placement is completely random. It only checks for an empty tile in a room. But it does work. So we can knock that off the list. And figure out what's wrong with that seed generation. The thing is, I do that in GIMP. So I would probably have to add that to the OBS. But first, let's make sure that the stars actually generating didn't change how the dungeon appears. It shouldn't, but you'll never know for sure. So with seeded generation, it will take a while to load, I guess. Okay, the stars are placed, but the issue with the generator persists. So I guess you're going to see how I do debugging. First, I need a good screenshot of the map. This, for the record, is exactly what I was doing when I said in the devlog that I was manually reviewing the generation algorithm. So let me get that open and then share the GIMP onto the screen. In the meantime, we can pause the NetHack itself. And okay, window, GIMP. I guess to make it more readable, I am going to set it up more like this, because then I can make it, well, actually I don't want to make it too big because I need the console to be visible as well, so this is probably good enough. Zoom in and let's see what we have. Sixteen rooms in a 4x5, starting at 10 forced east, meaning that this was the first one, forced in this direction, and then rule 1 naturally forced this one, rule 2 of the generation added the connection east. Then the second, this one had to be the second one to collapse. Oh, I guess to match what the console is outputting as the indexes, I should start at 0. And this obviously had to create a connection here. It is a little difficult to see what the grid looks like for this map, so maybe I'll draw that as well, because it's something like this. And I suppose the fact that it is so crooked is actually a good sign, because it means that the offsets that I'm generating are in fact working. Oh, and I did it wrong. Over here, it goes all the way there. Then over here, we have one room. Here we have 1, here 1, and 1. And then here, pretty much like this. And then rows are easier to define. And yes, we can continue. Rule 2, again, under the connection east. So when this one collapsed, and it collapsed into a four-way, it added a connection here, and it added a connection here, and here. Yes, 3 of them. Then 0, 2, which is this one, also got a connection east. And then, because 0, 2 over here could separate this area from this one, rule 3 got triggered, and as a result, 0, 2 also got a connection west. And because it had the most connections, it was the next one to collapse. And again, created a forced connection here and one over there. Then, because we had 2 areas, rule 2 triggered twice. And 0, 3, being this one, got a connection south, while 0, 1 got a connection west. Number 4 was 0, 1, however we can safely ignore this one. We can safely ignore this one because it doesn't concern the lower part of the map, which is where the issue occurred. So number 5 was 1, 3, being this one. It again collapsed into a four-way, forcing connections these ways. And as a rule 2, it added a connection south here. And then, because this one over here is a split, it got the connection north, as connection south already had a different one, so it didn't need to have one assigned there. And then we collapsed 1, 4. So it is number 6, forcing a connection here and here, not that this part matters. And rule 2 happened to add a connection west there. Rule 7 collapsed 0, 3, which is of no concern. Step 8 collapsed 2, 3, which is more notable, as this one collapsed into a four-way as well, meaning forced connections here, here, and there. And then 3, 3, which is this one. Okay, yeah, this one. This one got the connection east. And because of the split, it also got the connection west. So it collapsed next. This one here, this one there. this one here, this one there, and then those are rule 1, rule 2 added to a 3-4 connection north, which we don't really care about. Step 10 and 11 collapsed 2-4 and 3-4. Which we do not care about again. 12 collapsed 0-4. Again, not a concern. 13 collapsed 2-2, which is one that actually matters. 13 here. It forced a connection here, and it forced a connection here. From rule 1, it did not trigger rule 2. Is this where the issue came from? It does seem like that's where the problem originated. Rule 13 over here, because of rule 1 made the forced connections to the left and down. However, for some reason, when checking rule 2, it didn't see the need to add any connections. Meaning that rule 2 did not do what it is meant to do, failing at the step that detects if it's necessary. And that to me sounds like the list of open connections wasn't updated correctly. Although I can't see when that would happen. I guess we're going into the code and investigating it now that we know that room 13 is to blame. We could add an additional debug log for rule 2 and see what that tells us before guessing what is going on. Rule 2. Forge area among open connections. If it has less than 2 inward connections, add a forced connection to a random tile in that area. That is what it's supposed to do. Now what it actually does. For each area and its connections and connections by area, I guess a good start would be to log that. That is probably good enough to start with, since it will tell me if the problem is with the rule itself or with the fact that the areas end up having an incorrectly displayed number of connections. So this time when we generate a seeded game, the result will be the same, but we'll have more data to work with. As we can go directly to room 13, and it processed area 2 with 2 connections. So according to it, there were inward connections. Let me get a different color. Over here. And at 2, 1 over there. It doesn't make any sense for it to detect that the connection heading right was the inward one. But it seems like it could possibly be an overside where it considers connections heading towards the room as the inward connections, despite the room just getting determined. That is the only thing that makes sense to me, so I'll continue on with that assumption and see if I can fix it. We take them from open connections, and when are open connections added? Oh, right, we don't take it from open connections, we take it from the connections. Those are open connections, and we are looking for inward connections. So this is the one that we want to know where it gets its values from. Because while it doesn't make much sense, the only explanation I can see for why they would be in those positions. Also, I should probably hide GIMP when not actively working in it. Professional streamer, I know. So that we can actually see the code. This area for inward connections. It clearly detected types in the area, However, these tiles should not be a part of the forced inward connections. They are forced outward connections, as they are added by rule 1. Yeah, there are added two undetermined positions forced connections. So they are not added to the other ones. So it does happen on rule 3 flood, which makes sense because rule 3 does add outward connections. They are taken away, so that's probably not relevant here. Over here, their number is increased, which is when a room divides an area. However, that should not be applicable. And the third place is within rule 2 itself. This is not making sense. No, wait. I am logging the wrong thing, aren't I? Yeah, I am logging these connections. So yeah, go figure, it doesn't make sense. We want this, and we want I guess it wouldn't hurt to see the actual connections by area are open connections, so that is not what we want. What do we want? We have force connection count per area, but I guess we don't have specific connections. Area tiles, area. This is not ideal. It will throw as a debug log every single tile in the area, but it is something to work with. It might actually show that the area actually has incorrect tiles. So if you'd ask me, it's worth a shot, and also, thinking about it so late, it's not the most fun. So we can just ignore the generator, let it do its own thing, as we search for number 13. And pulling GIMP back up. The area that it should be locking is these 5 tiles. So it is 2 0, 3 0. It's 2 1, 2 0, 3 0, 3 1, and 3 2. So that part is correct. But it is area 2. Before number 9 was placed, it also had this, 9 itself, and yeah, that much. And I suppose when it had that, there was potential for an issue where it split the area, but it did not correctly reassign who does and does not have inward connections. So we would have to have a look at number 9. We started flat fill for area division at 3 4. Yeah, so the area division started at 11. And it created area 3 with 2 tiles. That part is correct. I suppose number 9 had 2 inward connections. And it's possible that it removed the inward connections of 10 and 11, but not the 9. That does sound like an oversight I would make. So let's check. Since it sounds like the blame lies with area division. Right here. Wait, does it? This looks like it was supposed to... It looks like it was supposed to count inward connection rooms. Has inward connections is a bool, but it sounds like it should instead be an int. Are we using it anywhere else? Yes, we are. However, that is... No, in 2 places it would actually help. to change that to int and call it get inward connections count. Can you just do that? Probably not. No, you probably can't add bulls. What's the smart way of doing it? I guess we have inward connections that we are adding stuff to. So instead of all this nonsense, it should be enough that we return the bit count of inward connections. But I can't remember the exact way that's written. Oh, it's okay. It just count bits. Count bits of inward connections. No? Does it have to be cast to int first? It does. So then, in the actual use cases, get inward connection count greater than 0. And here we could instead subtract the inward connections count and do the same thing over here. Inward connections count for current row column, and we replace that with inward connections count is greater than 0. We increase this by inward connections count and decrease this one by inward connections count. I'm not sure if that is enough to fix, but it's worth testing, I guess. Alright, so we generate by seed again. And this time it will be worth checking if the map maybe just generates right this time. One can hope. And what do you know? It does. It's slightly chaotic. Sorry about that. It's slightly chaotic, but it does work. so I'll just make a note on what that was. Okay, and I can now go ahead and remove that from the list of tasks. And move on to, I guess, return to writing the star generator. Which is this one, where for each count and for the tile keys, for each of these there is a need to get a random generator, so I will need an index. Shared key generators of index tile occupied dot inherit tile data from not map builder but tile dictionary tiles. And next, after that, index plus plus. And then each generator in shared key generators needs to be destroyed. Which, technically speaking, that it will be returned to the pool, but same difference. Now, if I add that to the generator dictionary, yes, if I add this one to generator dictionary as a stairs, I guess just stairs, and it's a new spawn tiles generator. Key stairs, name stairs generator, appearance stairs generator. Sure, it can be yellow if the AI wants it that way, I really don't care. Tile keys is S and S. Spawn count is 1. I believe that's all. And now within rooms, I would actually have to define where you can spawn. Oh, it will have to be when spawning objects from the generator, it will be important. Oh, we're spawning objects from the rooms of the generator, it will be important to take into account the room being flipped or rotated, because that is something I did not do, and that might cause issues. For now, I am going to set up the cross room as a potential location. So that is 0, 1, 2, 3, 4, and 0, 1, 2, 3, 4, 5. I never noticed that I messed up the size of the cross. It should be wider. Like this. So then it is at 5, 5. And we can do generator dictionary, generators, stars, at 5, 5. Another room that could have stairs is a white hallway. I will also have to take into account, I suppose, the fact that you can have the rooms extended, and that could affect the placement of the stairs. So maybe I'll leave the extending ones for now. For proof of concept, it should be enough that one room has a generator. And I think that should be enough to test it. Let's try. Alright, so I can immediately see that the generators were not erased properly. But on the bright side, it means that they did appear. And, well, this is exactly why I gave them the name as the appearance, so it is immediately obvious if something is wrong. That being said, I do not understand why that happened. There were multiple of them, meaning that the proper generator function had to be called. name at tile occupied row tile occupied column. That will tell us if it even tried the destruction, but also I guess fallback already logs when it happens. So it is just the spawn tiles generator. Destroying generators count generators, because the destruction code itself should work since it removes it as an object from the tile it occupies. And the tile's appearance after the visual update is forced. There. If there is no large object, then it should return the reference tile appearance, yes. So why is it not doing that? We set large that could be the issue, that this isn't nullable. I do not like the fact that you have to manually set stuff as nullable in .NET. But this is the first time where it became an actual issue, at least a potential one. I guess we'll see if generating fixed things. It did not. Let's see. We did have multiple star generators. There it is. Despite the fact that we had multiple of them, the fallback was called. So that's issue number 1. I suppose that's not the main issue, but still something that needs addressing. Did I give the generators the wrong key? Is that what's happening? The key is stairs, and the key is stairs, so no, that's not it. Alright, so I think I'll call the stream here. I do need to figure out what is going wrong with that, and right now it is too late for me to do bug fixing. I could do implementing new stuff, but this, well, this not working is stopping me from doing that. So until the next time, farewell.